This is SpaceTime Series 25, Episode 123, for broadcast on the 16th of November 2022. Coming up on SpaceTime, astronomers conclude that magnetars have solid surfaces, growing speculation that SpaceX could try launching its new Starship rocket to orbit next month, and Rocket Lab fails a mid-air rocket retrieval test. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart-Gary.
Scientists claim that Magnetars, a type of highly magnetized neutron star, has a solid surface with no atmosphere. The stunning conclusions reported in the journal Science are based on the signature of X-ray light emitted by a magnetar and provide new details about these enigmatic stellar objects. Magnetars are neutron stars, very dense remnants of massive stars between 8 and 20 times bigger than our Sun, which have exploded as supernovae at the end of their lives. But unlike other neutron stars, magnetars have immense magnetic fields, the most powerful in the universe. They emit bright X-rays and show erratic periods of activity with the emission of bursts and flares, which can release in a second millions of times more energy than our Sun will emit in an entire year. They're believed to be generated by their ultra-powerful magnetic fields, between 100 and 1,000 times stronger than a standard neutron star. The new findings were included in data from NASA's Imaging X-ray Polarimetry Explorer spacecraft XP, which was launched last December. The mission has provided a new way of looking at X-ray light in space by measuring its polarization, that is, the direction the light waves wiggle. Astronomers were examining XP's observations of a magnetar catalogued as 4U0142+61. It's located in the constellation Cassiopeia, about 13,000 light-years away. The authors were surprised to find a much lower proportion of polarized light than would be expected if the X-rays were passing through an atmosphere. Polarized light is light where the wiggle is all in the same direction, that is, the electric fields vibrate only in one way. It's like when you look at a plasma screen with polarized glasses on, and then tilt your head to one side, and the image on the plasma screen appears to disappear. And on a big enough stage, an atmosphere on a neutron star would act as a filter, selecting only one polarization state of light. The team also found that for particles of light with higher energies, the angle of polarization, that is the wiggle, flipped by exactly 90 degrees compared to light from lower energies. And that follows what theoretical models would predict if the star had a solid crust, surrounded by an external magnetosphere filled with electric currents. One of the study's authors, Sylvia Zane from the Mallard Space Science Laboratory, says the discovery was completely unexpected. She says she was convinced that there would be an atmosphere. Instead, the star's gas had reached a tipping point and become solid in the same way water might turn to ice. Zane says this is a result of the star's incredibly strong magnetic field. But like with water, temperature is also a factor. A hotter gas would require a stronger magnetic field to become solid. She says the next step will be to observe hotter neutron stars with a similar magnetic field to investigate how the interplay between temperature and magnetic field affects the properties of the star's surface. Quantum theory predicts that light propagating in a strong magnetized environment would be polarized in two directions, parallel and perpendicular to the magnetic field. The amount and direction of the observed polarization bear the imprint of the magnetic field structure and of the physical state of matter in the vicinity of the neutron star, providing information that would otherwise be inaccessible. At high energies, photons polarized perpendicular to the magnetic field are expected to dominate, resulting in the observed 90-degree polarization swing. The polarization at lower energies tells scientists that the magnetic field is likely so strong that it turns the atmosphere around the star into a solid or a liquid, a phenomenon known as magnetic condensation. The solid crust of the star is thought to be composed of a lattice of ions held together by the magnetic field. The particles wouldn't be spherical but elongated in the direction of the magnetic field. It's still a subject of debate as to whether or not magnetars and other neutron stars have atmospheres. However, the new paper is the first observation of a neutron star where a solid crust is a reliable explanation. This is SpaceTime. Still to come, rumours abound that SpaceX could try launching its new Starship rocket into orbit next month, and Rocket Lab fails its mid-air rocket retrieval test after successfully launching a new Swedish science satellite. All that and more still to come on SpaceTime. Well, while all the world's media are focusing on NASA's SLS rocket and the Artemis 1 mission, there's another even bigger rocket being built, this one by SpaceX. And there's growing speculation today that SpaceX could try for an orbital test flight of its new Starship Super Heavy sometime next month. No Starship prototype has taken flight since May last year. And all test flights so far from SpaceX's Starbase, the South Texas Boca Chica launch complex, where the rockets are built and tested, have so far been limited to altitudes of just 10 or 12 kilometers, specifically testing different aspects of the new launch system. And while observers have seen the 50-meter-tall Starship mounted on its 70-meter-tall Super Heavy booster from time to time, they've also seen the two units pulled apart again, and then remounted together, then pulled apart again. No firm date for the maiden test flight to orbit has so far been given. But back in September, Elon Musk, the head of SpaceX, tweeted that he expected to have 2 Starships and 2 Super Heavy boosters ready for orbital flight in November, with full production seeing a new Starship and Super Heavy booster built every 2 months. Musk's tweet noted that Super Heavy boosters B7 and B8, together with Starships S-24 and S-25, are likely to make the first orbital flights. Combined, the Starship Super Heavy will be the world's biggest rocket, able to carry payloads of more than 100 tons into orbit. Elon Musk sees Starship as an interplanetary colonial transport system, carrying people and cargo across the inner solar system, to the Moon, to Mars and beyond. Once operational, Starship will replace the Falcon 9, the Falcon Heavy, and the Dragon capsule. NASA have already contracted SpaceX to build a modified version of Starship called the HLS, or Human Landing System, to shuttle crew and equipment between the Orion spacecraft and the lunar surface on the Artemis 3 man-moon mission slated for launch in 2025. After that, the HLS will be used as a shuttle, transporting people and supplies between the Lunar Gateway space station and the lunar surface. Current plans call for 2 Starship Super Heavy launch pads at Boca Chica, and NASA and SpaceX have also signed an agreement to build a new launch complex known as Pad 49 at the Kennedy Space Center at Cape Canaveral, which will include both a Starship Super Heavy launch pad and a vehicle assembly building. And as both Starship and Super Heavy are designed to be reusable, landing pads will also need to be constructed. Meanwhile, a SpaceX Falcon 9 rocket has successfully launched Eutelsat's new Hotbird 13G telecommunications satellite into geostationary orbit. The mission was flown from Space Launch Complex 40 at the Cape Canaveral Space Force Station in Florida. After main engine cutoff and stage separation, the Falcon 9 first stage returned to Earth, landing on the drone ship Just Read the Instructions, which had been pre-positioned 670 kilometers downrange in the North Atlantic Ocean. The Hotbird 13G is the second of 2 satellites built by Airbus Defence and Space for Eutelsat to replace 3 older satellites. It follows last month's launch of the Hotbird 13F. Each of the 4,500-kilogram spacecraft are based on the new all-electric Eurostar Neo satellite bus, and each are fitted with 80 Ku band transponders. The pair will support broadcast of more than 1,000 television channels into homes across Europe, North Africa, and the Middle East. The Hotbird 13G also houses an L-band for the European Galileo Global Satellite Navigation System. This is SpaceTime. Still to come, Rocket Lab fails in its mid-air rocket retrieval attempt after launching a new Swedish scientific satellite. The ozone hole continues to shrink. And later in the science report, scientists develop a neuroprosthesis which really can read your mind. All that and more still to come on SpaceTime. Rocket Lab has failed in its latest mid-air retrieval attempt to catch an Electron rocket by helicopter for reuse. The disappointing result followed another successful launch for Electron, which placed a science satellite into orbit for the Swedish National Space Agency. The Mesospheric Airglow Aerosol Tomography and Spectroscopy, or MAT spacecraft, will investigate atmospheric waves and how the upper layers of the Earth's atmosphere interacts with winds and weather patterns closer to the ground. MAT was launched from Pad 1B at Launch Complex 1 on the Mahia Peninsula on New Zealand's North Island. The spacecraft was successfully deployed into a 585-kilometre high orbit. It was the 32nd Electron mission launch and the 152nd satellite deployment by Rocket Lab.
AVPs are on internal power, vehicles fully on internal power. AFTS is green and enabled for flight.
Flux load is complete, system is in recirculation. Anti-geysering is disabled.
Stage 1, Stage 2, rest for flight.
High flow engine purge enabled. Deluge is activated.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Lift off.
Beginning to pitch over.
Stage 1, propulsion, nominal.
At Lab Launch Complex 1 and is on its way to space carrying the MAT satellite. Our rocket recovery attempt is also now officially underway. Coming up on supersonic speeds, Electron will be traveling faster than the speed of sound as it approaches its first mission milestone, maximum aerodynamic pressure. Electron's Rutherford engines will throttle down slightly to pass this pressure point, and once cleared, we should hear the call from Mission Control that the rocket has passed max Q.
Vehicle is supersonic, approaching max Q, and vehicle has cleared max Q.
Stage 1,
there we go.
propulsion,
As expected,
holding
Electron has cleared that first milestone and is continuing nominally. Electron's Rutherford engines will now throttle back up as the mission continues on, and all looks nominal for propulsion there. In about a minute, we will reach the point in the launch when
Stage
Electron
1 guidance
separates
is nominal.
itself. Known as stage separation, the Rutherford engines on the first stage will shut down for the rocket to safely separate before the engine on the second stage can fire up and carry on with the mission. The calls for these events will proceed as MECO, or main engine cutoff, stage separation, and then second stage engine start. And here is when our recovery team
Stage 1
begin
propulsion
their
nominal,
countdown to the
standby for
helicopter
MECO in
catch
roughly
as
30
the
seconds.
first stage will begin its journey back to Earth.
15 seconds to staging.
Entered burnout detect mode.
MECO confirm.
Stage separation successful.
Stage 2 ignition.
We have had a successful MECO and stage separation, followed by the engine on
Stage two
Electron's
propulsion
second
nominal.
stage igniting successfully. For recovery, the first stage is now beginning its journey back home.
Discharge
The
nominal.
trajectories for both stages are looking good so far. The next mission event will be fairing separation on the second stage, coming up in just a few moments.
Fairing jettison succeeded.
In fact, actually, there it goes. Electron's fairing has been deployed, and MAT is now exposed
Stage
to
2
space
guidance is
while
nominal.
remaining attached to the rocket's second stage as it continues on the path to orbit. The vehicle is now traveling at a speed of more than 8,000 kilometers an hour with an altitude of 129 kilometers. Meanwhile, Electron's first stage continues its migration over the South Pacific Ocean. When it separated from the second stage, it was traveling at such high speed that its trajectory continued upward from the momentum. But in another minute or so, it is expected to reach the highest point of that arc, otherwise known as the apogee, and from there, descend toward the capture zone where our recovery helicopter is ready and on standby to proceed. We should hear the call out from Mission Control.
Stage 2 propulsion, still nominal.
The telemetry data for both stages is coming back nice and clear, showing the progress of the first stage. We're just starting to see that arc back downward as it heads towards Earth, as Electron's second stage continues to orbit.
Stage 2 guidance still nominal. 200 seconds remaining.
Electron's second stage continuing to orbit with propulsion firing hot and nominal. Fairly soon, Electron, though, will need another power source for Rutherford's electric pump cycle. We use batteries for this, but like all batteries, they run out of juice after extended
Still
use.
nominal.
So Electron performs an action called the battery hot swap, where it swaps over to a new
Entry
set
battery discharge
mid-flight
nominal.
to keep the
Retrieval.
engine running for longer.
Engine is starting to throttle down.
Hot swap successful.
Battery jettison confirmed.
There's that call from Mission Control. Battery hot swap is confirmed. We can confirm those batteries did swap over as planned.
Stage 2 propulsion,
Mortar
still nominal.
pressed. HVP discharge holding nominal.
Stage 2 guidance and terminal.
SICO confirm.
Stage 3 separation confirmed.
Nominal transfer orbit.
There we go. That's the call for SECO or second engine cutoff, and stage separation has been confirmed. That means Matt's and Electron's kick stage have commenced their first pass around Earth in its initial orbit. Around 40 minutes into this coasting phase, the kick stage's engine will light up to move it into a circular orbit position where payload deployment will be performed. But while Matt's takes a cruise, our pilots move in for the mid-air rocket catch attempt. With the stage hitting speeds of up to 8 times the speed of sound, we may actually see a glow at the bottom from plasma, which forms during the descent as a condition of a very fast atmospheric re-entry. Between the main parachute deployment and the time it would take Electron to reach the ocean, our pilots have about 10 minutes only to complete the catch, and catching a rocket with a helicopter is a tricky operation because within that time pressure, our pilots need to control the Sikorsky, balance the swing of the hook underneath while it's attached to the helicopter's line, hook it precisely to Electron's parachute line, and then secure the rocket beneath them for the journey back home. Now, right now, the mission is on track to do all of those things, but just in case, we are prepared with a nearby ship should we need to fish Electron out of the water instead today. Just a note on the soft water splashdown I mentioned before, if we did that today, that would not be a failure for our recovery program. In fact, we've performed several of them across our missions to date, and most recently, we were able to refire a Rutherford engine that had been returned from the ocean. Right now, though, we have an anxious wait with our fingers crossed until we might see Electron again. Our rocket spotter on board the helicopter has a few more tools to help them with this task, obviously. Those display screens that plot theirs and Electron's positions with telemetry and where they might intersect for that catch attempt. While the Sikorsky has been positioned out here over the ocean during mission operations, it's got a range of 950 kilometers. That means it can safely capture and return Electron to land following a successful catch. And now that Electron's first stage is empty of propellant, it will weigh approximately a ton in dry weight. Our Sikorsky, though, is rated to be able to carry up to 5 times that, so we've got good margins for a catch and carry back to land. Our Rocket Lab team back here at Mission Control, who are watching as anxiously as I am to see that Electron glide into view. Whether they've touched this mission themselves or have supported across some other functions through the business, everyone is just as invested in seeing Electron brought back to the factory. The recovery team themselves are stationed in various support locations. Some are in the Mission Control Center, others are on our recovery vessel on the ocean near the capture zone, and of course we have the helicopter pilots as part of that catch attempt too.
However, the mid-air retrieval of the Electron rocket's first stage by helicopter failed when telemetry from the spent rocket stage was lost, forcing crews to quickly move out of the capture zone on safety grounds.
Just had an update from the pilots, and unfortunately it looks like we are not going to bring Electron home dry today, but we do have the backup option of an ocean splashdown.
The Electron first stage ended up splashing down under parachute in the Pacific Ocean, where it was recovered by a Rocket Lab team and returned to the company's production facility for inspection and analysis. This was Rocket Lab's second attempt at a mid-air recovery of its Electron booster by helicopter. The first attempt also failed after the booster was successfully caught, but then deliberately released again due to unexpected flight behavior once hooked. Meanwhile, Rocket Lab slated to launch its first mission from its new Wallops Island Flight Facility launch complex on the Virginian mid-Atlantic coast next month. The Hawkeye 360 mission's been waiting until NASA certified Rocket Lab's Autonomous Flight Termination Unit, the rocket's self-destruct system required to enable Electron launches from Virginia. The Wallops Island Launch Complex 2 will supplement Rocket Lab's existing Launch Complex 1 site in New Zealand. The two launch complexes combined will be able to support more than 130 launches a year. As well as Electron, the new Wallops Island facility will also launch the company's big new reusable rocket, the Neutron, which is now under development. There's finally a bit of good environmental news out there. The latest data from NASA is showing that the annual Antarctic ozone hole has continued to shrink. The hole reached an average area of 23.2 million square kilometres between September the 7th this year and October the 13th. This depleted area of the ozone layer over the South Pole was slightly smaller than average for the same period last year and generally continued the overall shrinking trend of recent years. Chief Scientist Paul Newman from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says that over time steady progress is being made and the hole is getting smaller. Still, there's some wavering as to whether weather changes and other factors make the numbers wiggle slightly from day to day and week to week. But overall, there does appear to be a decrease over the past few decades. The ozone layer is a portion of the stratosphere that protects our planet from the sun's ultraviolet rays. But every September, it thins to form an ozone hole above the South Pole. Chemically active forms of chlorine and bromine in the atmosphere, referred to as chlorofluorocarbons or CFCs, and which are derived from human-produced compounds, attach themselves to high-altitude polar clouds every southern winter. The reactive chlorine and bromine then initiate ozone-destroying reactions as the sun rises at the end of Antarctica's winter. With the exception of China, which continues to emit large quantities of ozone-depleting chlorofluorocarbons, the world is abiding by the Montreal Protocol, which barred the use of CFCs in the 1980s. Researchers with NASA and NOAA, the National Oceanic and Atmospheric Administration, detect and measure the growth and breakup of the ozone hole with instruments aboard the AURA, SOMI-NPP, and NOAA 20 satellites. Last month, these satellites observed a single-day maximum ozone hole of 26.4 million square kilometres, slightly larger than last year. When the polar sun rises, NOAA scientists also make measurements with the Dodson spectrophotometer, an optical instrument that records the total amount of ozone between the surface and the edge of space, known as the total column ozone value. Globally, the total column average is about 300 Dobson units. But on October the 3rd, scientists recorded the lowest total column ozone value of just 101 Dobson units over the South Pole. At that time, ozone was almost completely absent at altitudes between 14 and 21 kilometres, a pattern very similar to last year. Some scientists were concerned about potential stratospheric impacts from the January 2022 eruption of the Hunga Tonga Hunga Ha'ape volcano. The 1991 Mount Pinatubo eruption in the Philippines released substantial amounts of sulfur dioxide that amplified ozone layer depletion. However, no direct impacts from the Tonga eruption have been detected in the Antarctic stratospheric data. This report from NASA TV.
Have you ever heard that something called the ozone layer is thinning? Or that your aerosol hairspray is what's causing it? Or that it leads to more severe sunburns and UV rays? This is referring to the ozone hole. But what exactly does it all mean? Welcome to Ozone 101. The ozone hole's proper name is actually the Antarctic ozone hole because when it forms over Antarctica. But before we get into what that is, let's first talk about what ozone itself is. Ozone is a gas comprised of 3 oxygen atoms. About 90% of the Earth's ozone exists in the stratosphere, the layer of the atmosphere that extends from 8 to about 30 miles above the Earth's surface. In fact, the stratosphere is often referred to as the ozone layer. Ozone acts as a sunscreen around the Earth, filtering out harmful ultraviolet radiation, or UV rays, which are mainly absorbed in the stratosphere. Without an ozone layer, UV radiation would sterilize the Earth. With a damaged but still present ozone layer, there would be more sunburns, more skin cancer cases, increased cases of eye damage, the wilting and loss of trees and plants, and significantly lessened crop yields. Suffice it to say, ozone is pretty important for the planet. So, what causes the ozone hole? There are several major factors that together lead to the destruction of ozone, thus creating the ozone hole. Those factors are 1. Very strong winds around the South Pole, or the polar vortex. 2. The sun's rays. 3. Chlorine and bromine compounds from ozone-depleting substances. And 4. Cold temperatures below negative 109 degrees Fahrenheit in the stratosphere, which form a specific kind of cloud, polar stratospheric clouds. The polar vortex forms in the southern hemisphere stratosphere during the winter as temperatures drop. And when sunlight returns to Antarctica in late winter and early spring, temperatures are still cold enough to form polar stratospheric clouds, and now there's also sunlight. Chemical reactions take place on the cloud particle surfaces, converting unreactive forms of chlorine and bromine into reactive chemicals. The vortex acts as a sort of container, confining the contents of the Antarctic stratosphere within its bounds, allowing the reactive chlorine and bromine compounds to destroy ozone molecules. That's when depletion can occur on a large scale. With the presence of sunlight, the reactive chlorine and bromine compounds produced during winter begin to deplete ozone molecules by stealing one of their oxygen atoms, leaving just oxygen gas, or O2, in its wake. As long as the polar stratospheric clouds are present, these reactions will occur over and over again, until the ozone is nearly gone. This forms what we call the ozone hole, but that's really a misnomer. It's actually more of a thinned layer. In mid to late spring, the vortex begins to break up, and the polar air depleted of ozone is mixed back into the rest of the southern hemisphere. The ozone hole is gone. Ozone depletion has still occurred, it's just no longer all concentrated in one small area. It's spread around the atmosphere. So why is the ozone hole bigger and longer lasting in certain years? Well, it all comes down to weather. Just like some winters are colder and longer than others on the Earth's surface, the same goes for weather in the stratosphere. If the Antarctic stratosphere stays cold, the polar vortex and the ozone hole within it will persist. And in years with cold springtime temperatures, the polar vortex and the ozone hole are large. Make no mistake, ozone depletion is not a natural thing. It stems from human emissions of chemicals called chlorofluorocarbons, or CFCs. In the early 1900s, refrigerators used toxic gases like ammonia and methyl chloride as refrigerants. Unfortunately, this led to fatalities as the toxic gases leaked out of the appliances. So the search began for a non-toxic and non-flammable chemical that could be used as a refrigerant. Thus, the CFC was born. There are many types of CFCs, but the two most common are CFC-11 and CFC-12. In the 1930s, the production and consumption of CFCs began to skyrocket. By the early 1980s, over 300 million pounds of CFC-11 alone were being released into the atmosphere each year. Then, in 1985, British researcher Joe Farman and his colleagues published their research on large seasonal ozone losses over Antarctica. Thanks to the combined efforts of the quick-acting science community, industry, and policymakers, the Montreal Protocol was signed in 1987, restricting the production and consumption of CFCs. Every nation on Earth has now signed the Montreal Protocol. So, for the record, your hairspray and aerosol deodorant hasn't been harming ozone since these laws went into effect in the 80s. But why do we still see an ozone hole today? First, CFCs have lifetimes of 50 to 100 plus years, and it will take some time for the concentration of CFCs in the atmosphere to drastically decline. Second, there are still CFCs being released into the atmosphere today. For example, as an old refrigerator or air conditioning unit deteriorates in a landfill, the CFCs within are slowly released. From the time a CFC is released into the air, it takes about 5 years for its impact to be felt over Antarctica, where depletion will occur. The CFCs emitted at the surface eventually rise into the tropical stratosphere. The ozone in the stratosphere blocks most of the sun's UV radiation, so the CFCs have to rise above most of the ozone layer before sunlight can then break them down. Once they get high enough, solar radiation releases the chlorine, most of which eventually goes into ozone-safe forms like hydrochloric acid and chlorine nitrate. When these compounds make their way to Antarctica, those chemical reactions start up. And if you're wondering why Antarctica, these reactions are unique to the polar regions because of their extreme low temperatures and presence of polar stratospheric clouds. One chlorine atom can destroy thousands of ozone molecules, and millions of tons of CFCs were pumped into the atmosphere from the 1920s through the early 1990s. As CFC concentrations in the atmosphere continue to decline, the ozone hole is expected to gradually become less severe, and scientists expect the Antarctic ozone to recover back to healthy levels around the year 2070.
This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. Scientists have designed a device capable of decoding brain activity in a patient with speech paralysis. The development could one day provide hope for people who can't speak or type. A report in the journal Nature Communications says that the neuroprosthesis device was designed to decode brain activity relating to single letters and spell out full sentences in real time. They then demonstrated its use in a participant who had suffered from limited communication because of severe vocal and limb paralysis. And the device was successfully able to decode brain activity, producing sentences from a 1,152-word vocabulary at a speed of 29.4 characters per minute, with an average character error rate of just 6.13%. In further experiments, the authors found that the approach generalized to large vocabularies containing over 9,000 words and averaging only an 8.23 error rate. So, it seems we've finally achieved the goal of a machine which really can read your mind. New data shows Australia's death rate fell by almost 6% during the 2020-2021 COVID-19 pandemic period, with 497 deaths for every 100,000 people, compared to an average of 528.4 deaths per 100,000 people during the period between 2015 and 2019. The findings, reported in the British Medical Journal, showed that the largest drop in death rates was for respiratory diseases, especially for influenza and pneumonia, although they also showed drops in deaths for cancer and heart disease. The study also used Google mobility data and found evidence that suggests that the drop in deaths was tracked with reductions in the movement of people outside the family home. The authors say the findings show that government lockdowns and social distancing appear to have significantly reduced overall mortality rates, at least in the short term, and this may help shape future public policy. More than 6.6 million people have now been killed by the COVID-19 coronavirus since it was first detected near China's Wuhan Institute of Virology around September 2019. However, the World Health Organization says the true death toll is likely to be over 15 million, with some 640 million confirmed cases globally, while the Lancet Commission, a panel of world-leading experts in policy and disease management, estimates around 18 million people have now died because of COVID-19. New studies have confirmed what parents already know. Using phones, tablets and other electronic media is associated with kids having shorter sleep times. The research by the University of Southern Denmark reviewed 49 studies published between 2009 and 2019 involving a total of 369,595 children. Researchers found that device use was associated with shorter sleep duration, and that the association was strongest in kids aged 6 to 15 years compared to children aged 5 and under. The authors also found a link between device use in children aged 6 to 12 years and delayed bedtime and poor sleep quality. In adolescents aged 13 to 15, screen time was associated with problems in falling asleep and social media use with poor sleep quality. The authors suggest the devices are overly stimulating because of the blue light from the screens, and this may be keeping kids up. And speaking of technology, Apple are in for a number of changes. They're improving their Siri security system. They're introducing a dynamic island, a sort of shortcut way of reaching apps on your device. With the details, we're joined by technology editor Alex Zaharov-Reutt from itwire.com.
Well, one of the changes is that Apple is reportedly looking to get rid of the word hey from Hey Siri. So when you say Hey Siri at the moment, it's 3 syllables. And somebody said, oh, well, Amazon just has one word, Alexa, but Alexa is 3 syllables, like Hey Siri. There needs to be a wake word, and already Siri can be triggered by so many different things. You can be waving your arms about, and your watch can suddenly say, I don't know about that, because listen to you say something, and you end up laughing. But you do realize how many times your devices are accidentally recording you because they think they've heard the wake word. And of course, changing it to Siri. Yeah, that's right. And you should go into the settings of Google Assistant or Alexa or Siri and tell it not to share the recordings with those particular providers, just simply so that they don't get these accidental recordings. They just get the ones that you meant to do. And of course, the information has to be sent to them anyway, but they're not at least associated, I suppose, with you or using it as any kind of feedback when you said no. So more Apple news, looking at a MacRooms article here. They're talking about iOS 16.2 coming in mid-December, and that's the version that's going to have this free-form app for iPads, Macs, and iPhones that lets you share this giant whiteboard that you can zoom into and zoom out of and make changes to and collaborate on. And it's this large canvas. You're not sort of limited to an A4 sheet of paper, but it can as big as you want, as big as your imagination. And that is coming with 16.2. There'll also be an update to macOS 13.1, watchOS 9.2, tvOS 16.2. There'll be more features included. You'll get also in the US, you'll get emergency SOS via satellite. Now that is only going to be, I think, in the US and maybe Canada, but definitely the US for the first couple of years. It'll be free. Now, over that time, they'll roll it out to other parts of the world, but at the moment, it's US only. But it's a very cool thing. I know I've driven on road going from Canberra to Havens Bay, for example, and there are stretches that there's just SOS. There's no mobile coverage. I've driven towards Cooma and Jindabyne, and if you go beyond that, there are stretches where there's no coverage either. If you had an accident of some sort, you would have to wait till another car came along. So at least this way, if you're conscious and you've got the phone, in the US at least, it'll come to the rest of the world later, but you'll be able to hold it up. You've got to hold it for a few minutes. It's not instant, not yet, but you can get a connection, send pre-canned messages, pre-written messages, and they can basically get emergency service out to you in a situation where otherwise you would have no choice but to wait for somebody to turn up. And so the last bit of Apple news I want to share is that I've been testing an iPhone 14 Pro Max with the dynamic island. And I really like it. I mean, it's obviously something that the competition hasn't copied. The closest I've seen is when you're looking at the Face ID sensor, which is usually not as advanced as Apple's, and it's letting you know that you can look at the camera, so it's sort of flashing a white circle around. But that's sort of the extent of the interaction normally that you get with the front-facing camera and any kind of notification around it. Whereas Apple has made this a headline feature. It's putting alerts, map turns, radio, media that you're playing, other information right in that area which can expand right in that little island. Go and look at YouTube at a video called Dynamic Island from Apple, youtube.com/Apple. It's very cool, but it's a great way of seeing additional information about the apps that you're currently using without having to change into that app and giving you the ability to interact with that app and bring it up just by tapping on an area of the screen. It's really cool, and I'm sure it's something that the Android people will copy in short order.
That's Alex Zaharov-Reut from ITWire.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from SpaceTimeWithStuartGary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to SpaceTimeWithStuartGary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTimeWithStuartGary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.